Hey everyone, welcome back to Game Code Mastery. Today, we are continuing our flexible action system in C++ that you can reuse across any project. By the end of this action system tutorial series, you'll have a fully working action system in C++ that you can reuse across any project. This system will handle all actions such as jumping, dodging, and attacking. This system will also manage when different actions should block each other, when they can combo, and how they interact with and manage your character's state. For example, controlling if you can attack while dodging or while in the air. Another example is a special state that activates a certain animation in your animation blueprint, and can also tell the action system to activate a special attack action if the attack is activated while a certain state is active. In the last video, we covered the design of our action system and implemented the action class, which is a base data asset that stores configuration for a specific action. In this video, we are going to build the action system component, which will be a reusable component that manages actions for an actor and handles what happens when they are activated. On top of that, we'll make use of gameplay tags to filter and organize actions. If you're new to gameplay tags, I recommend you check out my separate video where I cover them in detail. Okay, with that out of the way, let's go ahead and get started. Let's get started with actually building our action component. To follow along, you'll need to complete part 1 of this tutorial where we created and implemented functionality for the action class. We also created the action system component in that video, but didn't add anything to it yet. So that's what we are going to do in this video. If you did not create an action system component, you can simply open your project and create a new actor component class and name it ACS Action System Component. The only thing we've done to our action system component so far is remove some of the default auto-generated code, like the default comments and tick functionality. Something else I would like to do is slightly change our naming convention for our classes. For large projects, this might be more trouble than it's worth, but since this project is small, it won't be a big deal to change it. This will actually be a good opportunity to show you how to rename a C++ class in Unreal Engine. So you see how we have ACS underscore as a prefix for our class names. We are going to be removing the underscore. The reason we are going to do this is because in Unreal Engine, a common naming convention when creating child classes is to prefix the child class with the parent class name underscore. So for that reason, I think it would be cleaner for the base class to not have any underscore. Now, before we do that, I want to mention that this is optional. This is just something that I think would be slightly cleaner. If you want to, you can leave it as it is, and it won't ever cause any issues. So to rename a class, you simply have to go everywhere the class is referenced and change the name. So let's get started here with actually changing the file names. This might look slightly different depending on what IDE you're using. I'm using Rider, but in most IDEs, you have a sidebar and you can browse your folder structure, find a class, and you may have here in edit, you may have some properties here. We have rename option, so we can do that. And here we can simply remove the underscore. So let's uncheck all of this because for educational purposes, we are going to do everything manually. So we're just going to do a quick rename. Now, if you are using Visual Studio, this might look slightly different. Or if you can't do it in your IDE, you can always open in Explorer and just change the file name manually for both the header and CPP files. Okay, I'm going to do the same thing here. Remove the underscore. Then for the CPP files, edit, rename. In the action class, it looks like Rider already updated this for us, the ACS action.generated.h. So you need to make sure that your .generated.h file looks like this. So previously it might look like that. You just need to delete the underscore like we have with our class name. And for the for declaration, we need to remove the underscore. And here, we need to remove the underscore. You can search for it, Control F, ACS underscore, just to see if we missed it. And it looks like we have missed a few here. Okay, it looks like that has got that fixed. Now in the CPP file, you can see all of the red here. Let's go ahead and remove ACS underscore here from all of these. Okay, and now let's do the same thing in the action system component. You can see the .generated.h has been updated. So the underscore has been removed. Remove the underscore from here and from here and from here and here, here, and here. Okay, so make sure everything is correct, that the underscore has been removed from everywhere. Looks like everything is correct. You can just do a search for ACS underscore to make sure on each file. So now save all and close out Writer. Okay, here in your project folder, we need to delete some of the auto-generated files. Let's delete binaries, intermediate, drive data cache, and saved. Once you've done that, we need to try to open up the project. It should say the following modules are missing or built with a different engine version, and then the project name module here. Would you like to rebuild them now? Yes. Okay, that worked for me. Now, you may have an issue where you're in blueprints, the action class no longer has a valid class. Nope, it seems like we can't do that. Probably just need to delete it and create it again. So ACS action, select jump action, and for the action tag, action.type.jump. And if you think that the class name is a bit ugly and you don't like this prefix, we can actually change the way that it looks in the editor with a meta specifier. So we can say meta equals, then parentheses, display name equals, quotes, action. So this can be the display name for our action. Meta specifier keywords are used when declaring U classes, U functions, U properties, U enums, and U interfaces to specify how they behave with various aspects of Unreal Engine and the editor. In our case, we are changing how the name is displayed within the editor with the display name meta specifier. And in the action system component, since it already has a meta specifier, we can simply add a comma here. Display name equals action system component, and make sure your editor is closed and press Ctrl F5 so that we can compile and run the editor to see if our changes worked. Okay, so now let's go to miscellaneous data asset, and as you can see, it says action here. And if we open up a blueprint actor and try to add the action system component, as you can see, it says action system component here. So that's a lot better. Let's close the editor now. Next, let's work on the active gameplay tag functionality. As I explained in the last video, this system will use gameplay tags to create smart relationships between actions. In our action data, we have things like granted active tags, which are tags granted when the action is activated and removed when the action ends. This, in combination with the blocked tags, will determine if the action can activate or not. So let's go ahead and implement the active gameplay tags. Here in the action system component, what we can do is, here in the top public section, we can add a U property, parentheses, edit anywhere. So that way, this property can be edited within the editor details panel and in instances as well. Then here we can have blueprint read only. Category equals tags. Now we are going to make this an F gameplay tag container, and this will be the active gameplay tags. As you can see, this is red, so we need to add the include gameplay tag container.h. From the name, you can probably guess what this will be used for. We are going to use this to track the gameplay tags that are active for the action system. So let's create some helper functions to help us do that. First, we are going to create a function for adding tags to the active gameplay tags. Down here in this bottom public section, let's add a new function. This will be blueprint callable. Category is going to equal action system, and this will be void. Add active tags. Now this will be a const f gameplay tag container reference. Tags to add. I explained const references in the last video, so check that out for more details. But essentially, it's a more professional and memory efficient way to pass data through a function, because we are passing an alias of the data that cannot be modified instead of creating a copy of the data. And then the next one will be the same function. This function will remove tags from the active gameplay tags. So void remove active tags const if gameplay tag container reference tags to remove. Now let's right click, generate definition. The same thing for this one. And what this is going to do is we're going to modify the active gameplay tags dot append tags. And the tags that we are going to append is tags to add, then semicolon. What we are doing here is we are simply adding all the gameplay tags passed into this function onto the action system component's active gameplay tags. And here for remove tags, we are going to remove tags removed from the active gameplay tags dot remove tags. And the tags we are going to remove is tags to remove. Next, we are going to work on a way to know what actions can be activated and what actions have already been activated. To know what actions can be activated, we are going to create an array of available actions. The available actions is the array we are going to search when activating actions by tag. So let's create a T-array of type UASC action pointer. But instead of a raw pointer, we are going to use something different this time. We learned about raw pointers in the last video, but that was for local variables. Using raw pointers when declaring U properties is actually not the optimal way in Unreal Engine 5. When declaring a class member that is a pointer to another object, it is recommended to use TObjectPointer instead of raw pointers, which looks something like this. Property TObjectPTR arrows. Inside these arrows, you add the type name so that we can tell the compiler what type of object we want the TObject pointer to point to. In this example, let's use UObject for the type name. This is what a TObject pointer looks like. But why is a TObject pointer more optimal than raw pointers for member variables in Unreal Engine? TObject pointer allows the engine to monitor or track when an object is being referenced or accessed through its TObject pointer. This helps during development for things like ensuring the object isn't prematurely garbage collected while still in use, debugging unwanted access, lazy loading support, and more. However, much of these benefits are only useful for member variables. That is why it is recommended that you still use raw pointers for local variables and function variables, because those are intended as temporary references and they don't need the benefits of a TObject pointer. Let's go ahead and make this into our T-array, TObject PTR, and this is going to be for UACS action. And make sure you forward declare it like I have here, class UACS action. And this is going to be the available actions. We also are going to want to keep track of the current active actions, and we are going to do that with another array. It's going to be the same thing, except a different name. This is going to be the active actions. You might be wondering what the difference is between available actions and active actions. Available actions is the list we search when activating actions by tag. If we want an action to be possible to activate, we add it to this array at runtime. For example, a weapon might add its attack actions to this array when equipped. Active actions, on the other hand, keeps track of which actions are currently running. When an action starts, we add it to this array, and when it stops, we remove it. Now let's create some helper functions to add and remove actions for both arrays. So here in the bottom public section, let's create a U function. This will be blueprint callable. Category is going to be action system. And this one will be void give action. As an input to this function, we will add UACS action pointer. We'll call this action to give, or maybe something simpler like in action. We are also going to need a function to remove an action from the available actions array. Let's copy this, paste it here, void remove action, and we can copy this to remove. And instead of in action for this one up here, we can simply call this one new action. And let's do the same thing for the active actions. We can actually copy these, paste them here and give them different names. Add active action and remove active action. Okay, and now let's generate definition for these. Let's add the functionality. Let's check if not action. If the action is not valid or not new action. So if the new action is not valid, we are going to return. But before we return, let's do a UE log. So UE underscore log parentheses log temp warning. And let's add a text macro text quotes could not add action not valid. That way we log a warning instead of just silently failing. If it gets this far, we are going to get the available actions and add the new action. Now we're going to do something similar here in the remove action, but instead of new action, we need action to remove for this one, and available actions dot remove action to remove. Now we're going to do something similar for add active action, except instead of the available actions, we're going to add to the active actions. Actually, for this one, let's name it clear action. Go ahead and rename that. This one can be clear active action. Clear. Okay. Okay, now for clear active action, we can copy this one. But before we do that, could not clear action. Could not clear active action, not add active action. We need to make sure that this is not available actions, it is active actions. And the same for this one, for add active action, we need to make sure that we are using the active actions. Now let's create a function to search the active actions array and check if the action is active by tag. So let's copy this U function here. This will return a boolean, and we will call this one is action running. And this will take in an F gameplay tag, and we won't make this a const reference. So that way it makes selecting a gameplay tag easier from the blueprint. We will make this const and show context actions. Generate. We can do this with a ranged base for loop. A ranged base for loop is a for loop that automatically goes through each element in a container, like an array, vector, or list, without needing an index. You can think of it like saying, for every item in this box, do something with it. The syntax looks something like this. For, then you need your type here, and then the name, for example, element, colon, and then the container here, which is going to be like the array. And in here, you can use the element. In our case, type is going to be UACS action, and it's going to be a pointer, and then we can still name it element, that's fine. And the container is going to be the active action. Then we can check if element and element arrow operator action tag is equal to action tag. If that's the case, you're going to return true. And here outside the for loop, if we make it this far, we're going to return false. What we are doing here is we are looping through each action in the active actions array using a range base for loop. For each action, we check if it's valid and if its action tag member variable matches the tag passed into the function. If we find a match, that means the action is active, so we return true. If the loop finishes without finding one, the action isn't active, so we return false. You may have noticed the red squiggly lines here. Since we are trying to access members of this object, this class will need to know about that object so that it can access the members of that object. We need to add a hash include action system ACS action.h. And those lines are gone now. And you may have also noticed that we use the arrow operator this time instead of the dot operator. I explained earlier that the dot operator is what you use to access members when you have direct access to an object. And since the action is a pointer, we need to use the arrow operator to dereference the pointer and to access the member on that object. In this case, the action tag member on that object. If you didn't know, the arrow operator is syntactic sugar that combines two operations. The first is to dereference the pointer, which gets the object it points to, and then accesses the member on that object, which is the same thing as doing this. And then adding a star here, which is how you dereference a pointer. And then let's add a dot. It's essentially like an easier shorthand way to do the same thing. We can also make this const, because we do not change it. And we can make this one const as well, actually, because we are not changing this either. Okay, now let's also update the name for our element a little bit by adding a capital letter here, because in Unreal Engine C++, it is recommended that you start your variable names with a capital letter. Okay, and one mistake that we did make actually here, now that I'm realizing it, is for add active action and remove active action, we do not want this to be blueprint callable, because determining if an action is active or not will be exclusive to the C++. Next, we are going to need functionality that actually allows us to start and stop actions by tag. Otherwise, we have no way of selecting an action and controlling what happens when the action starts and stops. So let's go ahead and work on that now. Let's add this function above the isActionRunning here. And this one is going to be blueprint callable like this one. And this one will return Boolean start action by tag. Again, we will make this const if gameplay tag non-reference so that it's easier to select in Blueprint. Okay, now let's copy all of this and paste it below, and we can call this stop action by tag. Okay, let's create definitions for both of these. Okay, and we're going to do something similar to this one. We can paste that here, that we can remove this turn true. Within here, let's add an if not operator. For this one, rename this to action. So that way this one is a little bit more readable. Okay, so not operator, action, arrow operator, and start action. We are going to send this. So if it fails, we are simply going to continue. If you don't know what the continue is, it will basically skip the rest of the current iteration and jump to the next iteration of the loop. So that's what we are going to do if the current action element is not valid. And if we make it this far, we are going to get the action, arrow operator, and we are going to start the action. This. Now, since we are calling a non-const member, we actually need to remove const here so that this is no longer const, because this cannot be const if we are calling non-const member functions. Now let's add active tags and granted tags. So we are adding the granted tags to the active tags in the action system component. And then let's add active action. That will be the action. Then after that, let's return true. What we are doing here is we are looping through each action in the available actions array using a range based for loop. For each action, we check if it's valid and if its action tag member variable matches the tag passed into the function. If we find a match, that means we can try to activate it. Then we are going to check if the action can be started. Since we added the not operator, that means this will only run if the action cannot be started, in which case we continue. As I said earlier, continue skips the rest of the current iteration and jumps to the next iteration of the loop. But since we added the not operator, this only happens if the action cannot be started. Now, if we can start the action, then it's going to get the action here, then call start action on the action, which if we click on this, this is just going to be the function that we added to our ACS action class. And then we are going to add active tags, and the tags that we are adding is the granted tags. And after that, we are adding an active action to the active actions array so that we can know that the action we found is active. After that, we return true because activating the action was successful. And if it reaches the end of the loop and nothing happens, that means it failed. so we return false. For stop action by tag, let's do the same thing, except change it to stop action. So for here, instead of can start, it'll be can stop. Instead of start action, we'll be calling stop action. Instead of add active tags, we'll remove active tags. We will be removing the granted tags. Instead of add active action, it'll be clear active action. Okay, so it looks like we made a bit of a mistake I'm noticing here. So if we were to try this, this actually would not work. So the mistake that we made, if you didn't pick it up, is that we used the active actions instead of the available actions. And by default, there should be no active actions. So if you try to loop through the active actions and activate one of those, that's not going to be possible. So we need to make this the available actions, which are the actions that are available for activation. That's the point of that array. Okay, that should have the start and stop action functionality completed. Next, let's work on a notification system for our action system, because it would be nice to have the ability for other objects to know when certain things happen, like when the active gameplay tags are updated and when an action starts and stops. This will allow us to do things like notify the animation blueprint when the active tags have been updated to control when an animation is playing. This can also be used for things like letting an AI behavior tree task know when an action has started or stopped. But you might be wondering, how are we going to achieve that? We can achieve that through something known as delegates. In our case, we will use a multicast delegate. A multicast delegate allows you to broadcast a single event to multiple objects at once. It is Unreal Engine's implementation of the observer pattern, where multiple observers watch for changes from one subject. Think of it as a radio tower broadcasting to multiple receivers tuned to the same frequency. So multiple observers can listen for an event to happen from one subject. In our case, the action system component would be the subject, and everything that we bound to listen for these events will be the observers. The benefit of this is that the subject's code doesn't need to contain hard-coded references to specific observer classes. Observers can be added or removed dynamically at runtime without changing the subject's source code. The subject just says something happened and then lets the delegate system handle who gets notified, which makes multicast delegates perfect for one-to-many event notifications without tight coupling. This will allow us to notify other objects, such as the animation blueprint or a behavior tree task, without our action system needing to know anything about them. And the syntax for setting up multicast delegates in Unreal Engine is something like this. So we need to go to the top here, make some room, and in all caps, we need to type in declare underscore dynamic underscore multicast underscore delegate underscore, and then the number of parameters. For our first one, we are going to do one param, and then parentheses. Okay, and then here we need to add the name of the delegate prefixed with an F. So for this one, it will be F on action start, and then a comma, and now we need to add our parameter. So in order to add a parameter to a delegate, we need to add the type. In this case, it's going to be F gameplay tag, and then a comma, and then the name, which will be action tag. Okay, now we can copy this, paste it, and change this to on action stop. Now let's paste it one more time, and for this one, it will be F on active tags updated. This will be F gameplay tag container active gameplay tags. Okay, now we need to add them as U properties, which we can do here at the top. U property, and let's make this blueprint assignable. So that way we can assign the event and use it in blueprints. Category equal events. This one is going to be for F on action start. We will call it on action start. We can copy this, paste it, on action stop, F on action stop, paste it again, and remove all of this. F on active tags updated. On active tags updated. Okay, now let's actually put these to use. On stop action by tag. At the bottom here, let's add on action stop dot broadcast. And within broadcast, you pass in the action tag, which is going to be the local variable here that we pass into this function. And what this will do is broadcast that delegate for us. Like I said earlier, you can think of it as a radio tower broadcasting to multiple receivers tuned to the same frequency. So this is how we broadcast that. In this case, we are broadcasting that the action has stopped, and any observers that are listening for that event will be notified. We can do something similar here for on action start, broadcast, and we are going to pass in the action tags or action tag. And the next one we need to do is going to be for add active tags and remove active tags. On active tags updated dot broadcast, and we need to pass the active gameplay tags. And this is just on updated, so we need to call that on both. One thing I want to do before we continue is I want to slightly update the names for these functions. I want the naming for these functions to be more similar to some of the ones we have down here. Let's go to the header file here. Let's see if we can actually rename. So this should rename it for us and make it a lot easier to rename the function. I'm going to call it grant active tags. We can uncheck add core redirect because we haven't used the function enough yet for that to be necessary. And this one, rename to clear active tags. See if it's been updated in the CPP. Grant and clear. Yes, it has. So if you used a different IDE or you renamed it manually, just be sure change it here as well as in the declarations and then where they are called as well. In our case, here in start action and stop action. Next, let's implement a way to get a reference to the avatar actor. The avatar actor is going to be the actual pawn that is performing the actions. Various actions may need a reference to this actor, so it's a good idea to implement a way to handle getting and setting the avatar actor. We can do this by creating a private actor pointer called avatar actor, and then we can create accessor functions to operate on that data. Now you might be wondering why we would make our avatar actor property private and then create getter and setter functions. Wouldn't it be easier to put the avatar actor in the public section so that we can operate on it directly? Making a variable private and then creating getter and setter functions to operate on that data is a practice known as encapsulation. Encapsulation is a fundamental principle of object-oriented programming that involves hiding data within a single unit, such as a class, and then creating accessor functions to operate on that data. You can think of it like putting your data inside a locked box. You don't let other parts of the program reach directly into the box, because that could mess things up. Instead, you give the box a set of buttons on the outside. If someone wants to look at the data, they press the Get button, and if they want to change it, they press the Set button. This is both safe and professional practice. Most programming guidelines encourage encapsulation because it makes code easier to maintain, safer to use, and less prone to bugs. So let's take advantage of that good practice in our code. Let's go ahead and do that. Create a private section. Okay, so the first thing we are going to do is go to the top here and forward declare class a actor. Now let's create t-object tr arrows a actor. And this will be avatar actor. And we are going to need to add u property to this. This will allow Unreal Engine's reflection system to know about this pointer so that it can handle it properly during garbage collection. And next, let's create the getter and setter functions. We need u function, void set avatar actor. And as an input, we're going to add a actor pointer and call this an actor. We can implement this here because it's going to be very simple. You're just going to set avatar actor as the inactor. Okay, and then let's paste the u function here again. And this time it's going to return a actor pointer, get avatar actor. And it's going to be const, but instead of implementing that here, let's implement this one in the CPP file. And that is because we're going to do something a little bit special with this one. We're going to check if avatar actor is valid. In that case, return avatar actor. But if it makes it this far, that means the avatar actor is not valid. In this case, we're going to return get owner. We actually could just return the owner as the avatar actor, but The reason why we're doing it this way is because this gives us more flexibility. So let's say, for example, you add the action system component to something like the player controller. Well, in that case, the avatar actor would actually be the controlled pawn. You might want to set the avatar actor manually, which you can do by calling this function from your controller, and then when this is called, it will return the correct avatar actor. Next, let's implement a default actions array so that we can give actions to the action system component by default when the owning actor is spawned. This will be useful for actions that we want to always be available to the owning actor. So let's go ahead and do that. Let's add a third array and call this one default actions. Now this one will be edit anywhere, and the category will be action system. Okay, now let's put this to use. We should be able to do something similar to what we did down here. So let's just copy this for loop, paste it here in begin play, and instead of active actions, make this default actions, and then let's remove this, give action, and the action we are going to give. Let's rename element to action here. Let's give the action. Now you may have noticed an issue here because we cannot convert const UACS action to parameter UACS action. And we can fix this simply by removing const. Now another thing that would be useful for us to do is to create a function to handle playing an action montage. And the reason why we are going to create this function is because handling action montages is one of the things that our action system is going to handle. So it makes sense to create a function to handle playing an action montage. Let's make this one return a float and call it play action montage. The first input will be a class anim montage pointer montage to play. The next will be a const float play rate, and that's going to equal 1.f. The next one will be a const fname reference start section, and by default it's going to equal name none semicolon. Okay, now let's generate definition. Okay, and the first thing we are going to do is check is montage to play not valid. If that's the case, we are going to return 0.f. And if we want, we can log a message in this case as well, like we did earlier. And let's delete this action montage not valid. Okay, now what we need to do is we need to get a reference to the avatar character and then play a montage on that character. But we have a bit of a problem, and the problem is that we only have access to the avatar actor and not the avatar character. So since we only have access to the avatar actor, which is an actor, we need to convert the avatar actor to a character. And we can do that with something known as a dynamic cast. A dynamic cast safely converts a pointer from a base class to a derived class at runtime, returning null pointer if the conversion fails. It's like checking if a generic vehicle is specifically a car before trying to open its trunk. In our case, an A character is a child of A actor. So that means a character has what is known as an is a relationship with an actor. An is a relationship simply means that one class inherits from another. So a character inherits from an actor. A character is a actor. So that means we can use our avatar actor reference to cast to the avatar character. So to do that, let's create an if statement here. If a character pointer avatar character equals, and we're going to add a cast, which is our dynamic cast with arrows here. And we are going to be casting to type a character. And here in parentheses, and this is going to be the object we are casting to. In this case, get avatar actor. Okay, and as you can see, we are having an issue. That is because our action system component doesn't know what an A character is. We need to add an include. So let's add a hash include. This will be the game framework character.h. And that fixed up that issue. Now we need to return avatar character, arrow operator, play anim montage. Let's pass in all the inputs. Montage to play rate, and start section. Okay, and if it makes it this far, we're going to return 0.f because the cast failed. We've done most of what we need to do. Let's wrap a few things up, then compile and test in the editor. One thing we need to do before we compile is let's set canNeverTick to false, because we know that we will not be using tick in our action system component. Next, let's actually use the doesSatisfied requirements function, because currently we do not use it, and if we want our tag system to work as intended, then we need to make use of that function. So what we can do is go to ACS action, and here in ACS action in canStart action, let's first check if action comp. If action comp is valid, we are going to return does satisfy tag requirements, and we're going to get the action comp, dereference the pointer, and get the active gameplay tags member variable from the action component. If it makes it here, we will return false. And you may have noticed some squiggly lines there. It just means we need to include action system, and then ACS action system component.h. That should be all we need to do. Let's compile and run the editor. So I'm going to press Ctrl F5. Okay, my build succeeded. If your project didn't compile successfully, you need to keep in mind that C++ code needs to be exactly correct, and any small mistake can cause your code to not compile. I'm going to quickly scroll through my Now that our code has compiled and we are in the editor, let's create an example jump action to test our action system. Now we already created an example jump action. If we open this one up, you can see the action tag is action.type.jump, and that's the only thing we changed. Let's go to our player character blueprint, and here we need to add an action system component, and let's name this one action system component. Next, we need to click on the action system component in our character and go to the details panel. Here we need to find the default actions. We need to add the jump action. Now the default actions in the C++ is this array here that we created in the C++. And if you remember, we take all of the default actions and add them to the available actions array in our action system component. So that means on begin play, as soon as we play, all of these default actions will be made available to our character's action system component, including our jump action, which means this should work. So let's start action by tag. Let's plug this into started. So if you don't have a jump action, you can simply create one in the enhanced input system. And let's call stop action by tag on completed. So on start action by tag, let's select jump. Aim for stop. Now, if we want our character to actually jump when the jump action starts, we can simply add an onActionStart event. If we click the action system component, you'll see we have an onActionStart, onActionStop, onActiveTags updated. Let's add onActionStart. Now, those delegates that I showed you in the blueprint correspond with these delegates here that we set up in the C++. So this is the onActionStart declaration. This is the onActionStop. This is the onActiveActions updated. And another reason why they show up in the blueprint is because we made them blueprint assignable. And if you'll remember, here on start action by tag, we broadcast onActionStart. And same thing for stop action by tag, we broadcast onActionStop here. So these events should fire at the correct time. Let's add a switch statement here. Let's add action.type.jump, and here let's call jump. Copy and paste this. Let's call stop jumping. Okay, let's see if this works. I've pressed the jump button, my character is jumping. Now let's test if our active gameplay tags are working. So what we are going to do is let's go to our jump action. On granted tags, let's add status is falling. And for blocked tags, let's add status dodging. So if you need to create that, just simply add a gameplay tag and do it that way. And also, for testing purposes, let's add in the player character, right mouse button, get the action system component. Let's call a function that we created in our action system component called grant active tags. So this is going to grant tags to the action system component, make a literal gameplay tag container, status, dodging. And let's actually do this on a flip-flop. So essentially a flip-flop just alternates between A and B. If we press it once, it will do A. If we press it again, it will do B. So let's clear active tags, plug that in here. So first, let's test by hitting play and searching for the player character. In the outliner, click the player character, click action system, and here in active tags, press the mouse button, the right mouse button, it says status dodging. If I press it again, it removes it. So if status dodging is here and I try to jump, I can't. So that's working correctly. And that is because we added status dodging to the blocked tags for the jump action. If I press right mouse button again, it removes it and I can jump again. So we have confirmed that everything is working correctly. This video has become quite long, so I think this is a good place to end it. Thanks for watching, and I'll see you in the next part.